All right, so we're going to go over the 10.5 review and composite figures worksheet, all the answers. I'm actually going to go backwards and start with the composite figures since that was kind of our new topic, and then move into 10.5 since that's the review. All right, so I am going backwards here and starting with the composite figures, and I apologize that my somehow my scan got really diagonal here somehow. But you'll notice in the directions that it says to assume right angles. So if you look at number 13, this kind of T shape here, I'm going to assume that all of these right looking angles are right angles. And so I split it up into a rectangle on top and then a square on the bottom. You could also kind of split it by sort of going vertically like this, but so you would do like a 5 by 9 kind of rectangle, and you have to figure out the lengths on each of these sides. But I think this is the simplest way to split it up. So when you add them together, you're going to end up getting 69 centimeters squared. On number 14, we have a rectangle and a triangle here. So you'll see with my rectangle, it's just 8 by 13, so that's going to be 104 inches squared. Then since this whole length up here is 19 inches, if we subtract 13, that gives me this kind of length of 6 inches right here if I draw in that height for my triangle. And then the base of my triangle is still 8 inches, right? So you're going to want to kind of look at it tilted on its side. 8 is the base and 6 is the height. So 1/2 base times height, and I have those even flip-flopped in my formula there. But that'll be half of 48 or 24 inches squared for this triangle. Then when you add them together, you get to 128 inches squared. What I notice a lot on composite figures is people will forget to, divide their triangle by 2, or they'll forget to do one little step. And then when they add together, they get an incorrect final answer. So as always, I'm encouraging you to show your work, but really make sure you're focusing on showing your work so that if you have things that you're adding them together and you have one area wrong, that's going to throw off your whole final answer. Make sure you kind of show all the pieces there. On number 15, up here, we're just looking at a basic triangle, right? So base is 8, height is 7. So here's my triangle area is 28 feet squared. For the circle, you'll notice that we have a diameter of 8, if you can imagine kind of the rest of my circle here, but a radius of 4. So remember the formula for a circle for the area was pi r squared. I did pi times 4 squared, but this is a half circle. So I just went ahead right at the beginning and divided it by 2. So pi r squared is 16 pi. So the whole area of the circle will be 16 pi, but I want just half of that. So my area is actually going to be 8 pi feet squared. So then when I add them together, it says to round answers to the nearest 100. So I went ahead and used 3.14 times 8 for this 8 pi piece and got 25.12 plus the triangle 28 and got 53.12. But again, if you use the pi button in your calculator, you're going to get a slightly different value there for the 25.12. So don't be alarmed if it's a little bit different if you use that pi button, but it should be in the ballpark. It should be pretty close. All right, our last few composite figures here before we get to the 10.5 section. On number 16, remember we said either you're going to have to add the shapes together or you're going to have to subtract. So in this one, I see a larger kind of triangle shape, and then I see this square in here that's being taken out of the triangle shape. So the triangle area, the base is 10 meters, and then the height is 15. So 1/2 of 10 times 15 gives me 75 meters squared. And then I don't even have to do any subtracting. It tells me right here, and no, it's not to scale, but because it tells us the measurements here, we can just use them. It tells us that this is a 5 by 5 square. So I can just say, okay, that's 25 meters squared. Take the triangle, subtract the square, and that'll leave me with just these gray outside pieces, which would be 50 meters squared. On number 17, there was an example just like this in the PowerPoint that I left for you guys. The area of the square, since it's 8 by 8, is going to be 64 feet squared. And then the circle, right, because the whole length of the square is 8, that means if I go through the middle of the square, it's 8. So that's actually the diameter of the circle, right? That means the radius is 4 feet. So I'm going to do pi r squared, which is 16 feet squared. And if I use 3.14 for pi, I got 50.24. So I'm just going to subtract those two, and that'll leave me with just these gray kind of corners, and that gets me 13.76 feet squared. The last one, number 18, the outer shape. This one is almost the simplest one of all. The outer shape is 8 by 11 rectangle. It's 88 inches squared. The inner shape is 9 by 6 or 54 inches squared. And I want to only be left over with this gray part on the outside. So I'm going to subtract 54 from 88, and I get 34 inches squared. All right, so now we're back up to the top of the worksheet at number 1, which is the 10.5 review section. Remember that these are the problems that have a lot of work and a lot of little details, so please make sure you've shown as much work as you can. And I'll try to go through in as much detail as I can so that you can follow along and check your work very carefully. So on number 1, it tells us that we have a side length of 8 meters. That's all it starts us with, and it's an octagon. We can count that there are 8 sides. We know it's regular. So I just went ahead and multiplied by 8 and got my perimeter of 64 meters. So we know we need apothem and perimeter, so I'm going to start by finding my perimeter because it's pretty quick. Then I need to find the length of my apothem. So I called that x here. A lot of the times I've called it a in the past, but I have x here. So remember that if we split it up into 8 sections, right, because there's 8 radii that I could create around here, that splits me up into 45-degree angles as I go around my shape. But then when the apothem comes and splits it in half, half of 45 is going to be 22.5. So we're dealing with a 22.5-degree angle up here with a right angle down here from the apothem. I also know that this kind of base of the triangle is 4 because my side length is 8. So half of 8 gives me 4. So I'm going to use tangent, opposite over adjacent. So tangent of 22.5 equals 4 over x. Remember we have that shortcut trick where if x is in the denominator, we can just flip-flop it with tangent or with whatever's over here. The other way to do that is to multiply both sides by x and then divide by the tangent of 22.5. So I get that x equals 4 divided by the tangent of 22.5. When I plug that into my calculator, I get x equals 9.657. And remember that if you round to 2 or to multiple decimal places, you're going to maybe get a slightly different rounded answer here. But my equation was a equals 1/2 9.657 times 64, the perimeter, right? Because this is my apothem. And I got 309.02 to the nearest hundredth. But again, you might be slightly off because of how you rounded or whatever. So just make sure you're in the same ballpark as me. You should not have gotten like 600 and something or like 150, right? You need to get right around 309. On number 2, we're looking at a pentagon. All we know here is that the radius is 6 feet. So we are going to need to find the apothem and the perimeter. So because it's a pentagon, if we split it up into 5 sections, 360 divided by 5 is 72, and then the apothem cuts it into half of 72, which is 36. So I redrew my triangle over here. I'm looking for the apothem and then this kind of piece of the side length here. So here's my finding the apothem right here. I'm going to use cosine of 36, adjacent over hypotenuse, solve, 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 and I get that my apothem is 4.854. So then in order to find the sides or to find the perimeter, I'm going to go back to the original triangle and use sine, opposite over hypotenuse. So that's solving for x in my triangle. I got that x was 3.527, but remember that that's only half of my actual side length, right? So that's where a lot of people will end up getting half of the correct answer because they forget to double that side length. So the whole side length should really be approximately 7.06, right? And depending on how you round it. So that means my perimeter, if I multiply by 5, is going to be 32.27 approximately. So equation is area equals 1/2 apothem times perimeter, and I got approximately 85.60, but again, it depends on how you round. Make sure that you have your equation written here. And if you have the pretty much the same numbers here as me with maybe some slight differences in rounding, then we should get about the same thing at the end. On number 3, we're looking at a hexagon with side lengths of 4 meters. So here's my beautiful, perfect, lovely hexagon. Because it has a side length of 4 meters, I have split this length right here into 2 meters, right? Because it's half of 4. We know with a hexagon that all the radii are going to split it into 60-degree angles, 360 divided by 6, and the apothem splits it into half of 60, which is 30. So we actually in a hexagon have a special right triangle here. So if my short leg of my 30, 60, 90 is 2, I can just multiply by the square root of 3 and get my apothem to be 2 times the square root of 3. Then the perimeter is just going to be 4 times 6 or 24. So my equation, I went ahead and just used the simplest radical form and not a decimal here and got 24 squared of 3 meters squared. But then when you plug that into your calculator, you should get 41.57 meters squared. Number 4, we have a pentagon with side lengths of 10 inches. We've already looked at finding the angle up here for a pentagon. So we know that this base piece down here of the triangle is going to be 5, that shorter leg. So we are going to use tangent, opposite over adjacent, to figure out what the apothem is. I got approximately 6.882, and then my perimeter, 10 times 5, would be 50 inches squared. Plug it all in, and you get approximately 172.05. But again, it's going to look a little bit different depending on how you rounded it. Last couple of these problems here. Number 15 was a 15 gon with a perimeter of 150 centimeters, and I just didn't even bother because, man, my 15 gon is going to look real bad here. So what I did though was, because it has a perimeter of 150, I wanted to find just one of the side lengths. So I divided 150 by 15 and got a side length of 10. So this is just kind of like one triangular segment coming out of that 15 gon, right? If you can imagine, it's kind of going all the way around here. So then I figured out, okay, for what this kind of angle of the larger triangle is up here, if I split it up into 15 segments, is going to be 24 degrees. And then the apothem splits that in half to a 12-degree angle. So to find my apothem, if the side length is 10, then half of it, right, that little piece for this triangle here is going to be 5. I used tangent, opposite over adjacent, and got that my apothem was approximately 23.53. So my equation was 1/2 the apothem times the perimeter, and again, approximately I got 1,764.24 centimeters squared. Number 6, we have a decagon with a radius of 5 millimeters. So you can see I've kind of got a ton of stuff going on over here. So I've got my radius drawn in right here of 5 millimeters. So then if I have my decagon, it splits each little radius segment up into 36 degrees, and half of 36 is 18. So with my apothem, I have an 18-degree angle up here and a radius of 5 millimeters. So to find the apothem, I'm going to use cosine, adjacent, and hypotenuse, multiply both sides by 5, and I got approximately 4.755. Then to find the base of the triangle, which is going to help us to find that perimeter, I use sine, opposite over hypotenuse, and I got that my x value is approximately 1.545. And then remember that that's only half of the side length, right? So I have to double that to get the whole side length, which was approximately 3.09 for me. So then, because it's a decagon with 10 sides, we have to get the perimeter, which is multiplying it by 10, right? 3.09 10 times would be 30.9 millimeters. So hopefully you have all your work shown and you can kind of show you have your apothem here, your perimeter is 30.9, and you plug it all in here. My final answer was approximately 73.46. Again, make sure you're close in estimation. All right, our final section of our homework problems here, number 7. I drew in my height. I isolated my angle here and used sine, opposite over hypotenuse. I got that my height was approximately 3.709, and then my base was 6. Remember, the base is going to be perpendicular to the height. So my total area was 11.13 meters squared. Number 8, I found out that my height was approximately 5.991. My base was 12, right, because it's perpendicular to that height. And my area was approximately 35.95 inches squared. On number 9, when I draw in the height here, remember that we need to isolate this area. So there's a few different ways that you could have done this, right? We could have actually drawn in the height maybe going this way or going this way, but either way, you're probably going to end up with your height a little bit outside of the triangle. So when I did number 9, I actually just used the law of sines, which was 1/2 A times B, so both of the sides, and then times the sine of angle C, which was 99 here. So I got 17.78 centimeters squared. No matter how you draw this triangle, you should be able to get that same answer there. So same thing on number 10. There's a couple of different ways that we could go about isolating this, this angle here, but we should end up with 22.41 feet squared approximately at the end. On number 11, I drew in my height going this way, but we probably could have also drawn it in going this way. So again, your height might look a little different, but your area should end up being 46.36 millimeters squared at the end. Okay, so for number 12, I went ahead and started to sketch in my height of my triangle here, right? Kind of trying to isolate this 125, but no matter how I draw it, because it's an obtuse triangle, it's really not isolating my 125-degree angle. So what's really going on here is that I'm extending this length right here and subtracting from 180, right? So I would actually get a 55-degree angle going on right here. And then to find the height, I would probably want to use, well, I have to use sine again, right? Sine of h over 14, or sorry, sine of 55 equals h over 14. And that would help me find the height. Or I could do the same thing with drawing in my height from the 15 inches, but I'm going to have to also subtract from 180 and use 55. Or the other option is that we could come back to that law of sines, which should get you the same answer regardless, right? So I use the law of sines, 1/2 AB, which are the two sides, and then the sine of the included angle, which is 125. And that got me 86.01 inches when I plugged it into my calculator. And that's all for today.